A 1996 report from the U.S. Consumer Product Safety Commission claimed that at least 90% of all American homes have at least one smoke detector. A city's fire department has been running a public safety campaign about smoke detectors, consisting of posters, billboards, and ads on the radio, TV, and newspaper. The city wonders if this effort has raised the local level above the 90% national rate. Building inspectors visit 400 randomly selected homes and find that 376 have smoke detectors. Is this strong evidence that the local rate is higher than the national rate? We'll use our acronym PHANTOMS again, where P stands for the parameter. I'm going to assume that my parameter is exactly the national rate. So we'll say if the campaign doesn't work, P should be 0.9, which is the national rate. H is my hypotheses, so I should have H naught and H sub A. For H naught, I'll always have P equals. In this case, it should be equal to the 90%. And I'm trying to see if the local rate is higher than the national rate, so I'm trying to see if my P is greater than 0.9. Moving on to A, I need to check my assumptions. I'm looking if they are random. It does say that this was randomly selected. Checking the 10% condition next. So we selected 400 homes. 400 homes should be less than 10% of all homes. And then last, I need to check if I have enough success and failures. So I'm doing 400 times my 0.9. I get 360. And 400 times 0.10 should give me 40. Both of these are greater than 10, so my conditions are met. The N in PHANTOMS stands for naming the test. Again, this is a 1 proportion z-test. T is where I list my test statistic. So in other words, I'm listing my p-hat. In this sample of 400 houses, they found 376 that had a smoke detector. I'm going to change that into a percentage, and we get 94. Okay, next up in PHANTOMS, I have O. O standing for obtaining my p-value. So this is where I'm going to find my expected value and standard deviation. The expected value for p-hat should just be p, so 0.9. To find my expected value, I need to use our formula. So I'm going to take p, which is 0.9, times q, which is 0.10, and divide by the sample size of 400. Once I have my mean and standard deviation, I can draw my normal model. The mean is at 0.9 and each standard deviation is 0.015. The p-hat that I'm looking for from my sample is 94%, so it would be somewhere over here. Because I am trying to find out if my p was greater than the 0.9, I'm going to shade to the right, the greater than. To find that area, I first need a z-score, so I will convert my p-hat into a z-score. So we have 2.67. From here, I will use my normal CDF. My lower bound is the 2.67. Upper bound, a very large number. 0 and 1 are staying the same for mean and standard deviation. So we get 0.0038. Again, this is what we call the p-value. Now, because that p-value is quite small, it means that if the true proportion was in fact 90%, I would find a sample of 94% only 0.0038% of the time, so 0.38% of the time, which is not very often. From here, I'm going to make a conclusion. Again, that p-value is very small, so I'm going to reject the null hypothesis. So small p-value means I'll reject H0. On my last part here, the S making our statement, I need to bring this back to the context of the problem. So I'm rejecting H0, which means I do not think the true proportion is 0.9, meaning I do have evidence that suggests the true proportion is greater than 0.9. So I have strong evidence that suggests that the local rate of homes with smoke detectors is higher than the national rate. If you found a p-value that was large, what we would say is that we fail to reject H0, and we would say that we do not have strong evidence that the local rate is higher than the national rate.